So we're going to start by talking about a quadratic function. And remember, we talked about this before, our quadratic function in standard form looks like this. F of x equals ax squared plus bx plus c. This is in standard form, and that's what we're going to be working with today. Because very often, our quadratic functions come in standard form. They aren't conveniently written for us in vertex form. So, we're going to talk about how do we go about finding information about our function from standard form. Now, if you remember yesterday about how we rewrote a function in standard form into vertex form, you may remember one thing. This A is the same A in vertex form. All right? So, if A is greater than 0, then this is concave up. So it's going to look like this. What that means is that down here, it has a minimum value. In other words, a lowest value. All right? If A is less than 0, this is concave down. It's going to look like this. And up at the top here, it has a highest value. We call this the maximum value. All right? So we're going to learn how to determine if a particular quadratic function has a minimum value or a maximum value. And we do this by looking at A. All right? Now, if it's in this form, ax squared plus bx plus c, it is a parabola. It absolutely is. Now, the minimum or maximum value is actually the y coordinate of the vertex. And that means it's k. So our minimum or maximum value is the k value. On the y-axis, it's telling us the lowest value or the highest value. All right? Now, the whole issue is how do we find k from this? And we learned yesterday that we could take this function and rewrite it in vertex form. Today we're going to do this a different way. So I'm going to tell you a formula, and that is the x-coordinate of the vertex is x equals negative b over 2a. This is h. All right? And that means we're going to take this b and this a and use them in this formula. So we can find h from doing this. So let's go through an example here on the bottom of our page, and we're going to find our minimum or maximum, and we're going to find our vertex. So let's go up here. This is an ugly one. It's got fractions in it. So it says the minimum, find the following, the maximum or minimum value of f. Now first of all, a is 1/2. So a is greater than 0. If a is greater than 0, this is concave up. And it helps me, because I can always remember if it's concave up or concave down, if I draw a little teeny one just like this, and I go, oh, this is going to have a minimum value, a lowest value. All right? So I've already determined it's going to have a minimum value. The minimum value occurs where x equals negative b over 2a, which in our case is, I put a negative in front, my b is 3 over 2 times 1/2, which is a. 2 times 1/2 is just 1, so this is negative 3 over 1, which is just negative 3. Notice, this is our h value. Negative 3 is our h value. All right, here's how we find k. K equals f of h. All we have to do is take our h value, whatever it is, put it into our function, and we can calculate our k value from it. So here's what I need to find. I need to find f of h, which is f of -3. And we learned how to do this a long time ago. I'm going to plug -3 into this function. So I have 1/2 times -3 squared plus 3 times -3 minus 7/4. All right? So this is -3 quantity squared is 9 times 1/2 is 9/2. 3 times -3 is minus 9, and then subtract 7/4. Now, I need a common denominator in order to add all of these. That's a skill I know that you have, so we're not going to repeat it. I will tell you that this is -25/4. And this is our k value. So, we have a minimum value and it equals -25/4. Because your minimum value equals your k. All right, now we're going to find the vertex. All right, here's the thing. We already did. We found h and k. So the vertex is h, which is -3, and k, which is -25/4. That was our vertex. So you have to find your vertex to find your minimum or maximum value anyways. So now we have our vertex. So let's do this again. Let's go to the next page, and we've got another function. All right, so here is another quadratic function. A happens to be -4. So here's what we're going to say. A is less than 0. I know that this is concave down, which I know means it's going to look like this. So up here at the top, it's going to have a maximum value. And we've got to find out what it equals. Remember, it is going to equal k. We just have to find k. So let's go down here a little bit further on the page where it says find the vertex of the graph of f. All right? So first of all, let's do this. Let's find h. It equals -b over 2a. So this is -8 over 2 times -4, which is -8 over -8, which is +1. So h is +1. The way that we find k is we have to find f of h. So this is f of 1. And we're going to put 1 into our function. So this is -4 times 1 squared plus 8 times 1 minus 1. 1 squared is 1 times -4 is -4, plus 8 times 1 is 8, then minus 1. So -4 plus 8 is 4, minus 1 is 3. So k equals 3. And this means my vertex is 1, 3. So go back up here to the top where we needed to find our maximum value. That's our k value. So our maximum value equals 3. All right, let's do this again, but we're going to add some other information to our process now. We're going to add domain, we're going to add range, and we're going to add zeros. All right, all easy things to do. So the first thing here, I've got this quadratic function, but notice it's in backwards order. All right, it may be helpful to write it in the frontwards order, which is -3x squared plus 6x plus 6. All right? So now I have it written frontwards. So the first thing we're asked to find here is the vertex of the graph. Now, let me stop for a minute. Is this going to have a minimum or a maximum? Well, A is negative, so it's concave down, which as you recall looks like this, which means it's going to have a maximum value. All right? So my vertex, my H is negative B over 2A, which is negative 6 over 2 times negative 3, which is negative 6 over negative 6, which is 1. So there's my H. My K equals f of H, which is going to equal f of 1. So I have negative 3 times 1 squared plus 6 times 1 plus 6. All right, so 1 squared is 1 times negative 3 is negative 3, plus 6 times 1 is 6, then plus 6. Negative 3 plus 6 is 3, plus 6 more is 9. So my K is 9, and that means my vertex is the point 1, 9. All right, now we're going to find the domain of X, or F. Remember, domain means the X values. Now, let's just draw a plain old parabola for a minute. And I'm just going to draw this somewhere on a graph. And it doesn't really matter where. But the question is, when I ask what is the domain, is what X values are part of this graph? And the answer to that is all real numbers. And this is true of every single parabola. And the reason why is because if you draw your graph big enough, this will keep going further to the left, this will keep going further to the right. So it will go all the way from negative infinity to positive infinity. All right, you have to think of it in terms of if this graph is drawn infinitely large, this will go all the way to negative infinity, this will go all the way to positive infinity. So it covers every X values. So the domain of our function is all real numbers. And let's write down here, this is true for all parabolas. All right? Now the range is the Y values. The range is not all real numbers. And the reason why is because if you look at our parabola, and I tried to make this one like our example here, it covers the Y values from here down. There is no graph at these higher Y values. So the range is from this highest point down to negative infinity. And here's how we're going to write that. And how you write it depends on your value for A. Because if your A is negative, it's going to be from a point down. If you have a positive A, you're going to have a curve that's concave up, and it'll be from a point all the way up. So here's how it's written. Since A is less than 0, the range is, put this in a set, it's all Y such that, the colon means such that, Y is less than or equal to whatever K is. All right, K is the Y value of our vertex. And in our case, this is the number 9. All right, so this box here on the right tells you how to write this. So this is all Y's such that Y is less than or equal to 9. And it's not just less than, it's less than or equal to, because it's also this point 1, 9. All right, lastly, we're going to find the zeros of f. Remember something, the zeros, these are the x-intercepts. So if you recall, this is a point x, 0, and you'll have another one, x, 0. Now, if your graph doesn't have any x-intercepts, your zeros will be imaginary. All right? But we're going to still do this the same way we did before. Notice, the y value is 0. So we're going to set our y value equal to 0. But we have a function. Remember, that f of x equals y. So here's what I've got. I've got 0 equals negative 3x squared plus 6x plus 6. And I can solve this either by factoring, I can solve it by using completing the square, or I can solve it using the quadratic formula. All right, a lot of these you're going to need to use the quadratic formula for. But here's the thing, if you use the quadratic formula, it can still come out to a nice number like an integer. So that's what I'm going to do here. So a is negative 3, b is 6, c is 6. And let's just see what we get. So I've got negative b, which is negative 6, plus or minus the square root of b squared, which is 6 squared, or 36, minus 4 times a, which is negative 3, times c, which is 6. And this is all over 2 times a, which is negative 3. All right, so let me simplify this. So first of all, 4 times negative 3 times 6, this gives me 72. But it's minus a negative, so it's going to be plus 72. So I have negative 6 plus or minus the square root of 36 plus 72 all over negative 6. All right, 36 plus 72 gives me 108. So negative 6 plus or minus the square root of 108 all over negative 6. Now I need to simplify the square root of 108. I know that 9 goes into 108, but so does 4. So what I'm going to do, square root of 9 is 3 and the square root of 4 is 2. 3 times 2 is 6. 6 squared is 36. So my guess is 36 goes into this too. So 108 divided by 36 is 3. So this is the square root of 36 times the square root of 3. So this gives me negative 6 plus or minus 6 square roots of 3 all over negative 6. Now, this is wonderful. Everything divides by 6. So I'm going to factor out not just a 6, but since I want to get rid of this negative down here, factor out a negative 6. So I'm going to factor out negative 6, which is going to leave me 1 plus or minus the square root of 3 all over negative 6. Now the negative 6 cancels, and my answer is 1 plus or minus the square root of 3. And the last thing I can do is I can actually write this in decimal form. So 1 plus the square root of 3 is 2.73. And 1 minus the square root of 3 is negative 0.73.